Welcome back, chemistry students. Today you guys are going to learn about neutralization and acid-base titration, which is basically a form of neutralization. When you hear the word neutralization, maybe what comes to your mind is, okay, if I have an acid, I need to neutralize it, and the way to neutralize it is you add a base. So the opening slide here shows that some people get like heartburn and upset stomachs. A lot of times that's because they have too much of an acid in their stomach. So we take a base, basically maybe a Pepto-Bismol, and they'll take that and it'll make them feel a lot better because it helps neutralize the acid. Okay, so then what happens when we actually neutralize a reaction? Like, what is really going on? So reactions in which an acid and a base react in an aqueous solution to produce a salt and water is going to be called neutralization. So here's what happens. Anytime you mix an acid with a base, the outcome is going to be salt and water. This might look familiar to you guys when we learned about types of chemical reactions. Let me show you guys. So what's happening is it's undergoing a double replacement reaction. You guys can see that. One of the outcomes is the salt, and the other outcome is the water. So, and that is something that happens anytime you mix an acid with a base. So this is the common acid, hydrochloric acid, common base, sodium hydroxide. You actually get sodium chloride is the salt and the water. So I'll just put this as the salt, and obviously this would be the water. And you guys know that a salt is basically made of a metal and a non-metal, so salt isn't just limited to sodium chloride. So like in this example here, this is also a neutralization reaction. What happens is we do form a salt and we do form water. So I'll just connect that so you guys can see it. The salt this time is potassium sulfate. It is a salt. When you mix it together, you do have your salt and water. So it basically neutralizes it. All right. Here's a list of some common salts and some of their applications. You have barium sulfate. You have calcium chloride. That's a common salt used for de-icing roadways and sidewalks. You have silver bromide, which is a photographic emulsion. Then you obviously down here you just got sodium chloride. That's a body electrolyte, very important for us. So that's kind of neutralization reactions. The next thing that I'm going to teach you guys is titrations. So you might be wondering, what's a titration? Well, it's this. It's the process of adding a known amount of solution of known concentration to determine the concentration of another solution is called titration. So we're starting with a known amount and we're using it to figure out the unknown concentration. I got a picture showing you what the titration is. I'll go back to these other vocab words. So here's what would happen with an acid-base titration. So in the flask, we would have an acid in here. It's going to have a X amount of milliliters. We would know that, okay, so we would know how much we're starting with here. We would titrate it with a base. So in this one, we'd have a base, and this would maybe have a known molarity. Maybe it's 1 molar. And then what we would do is we would slowly add the base, okay? So then that way, you know, and these things are really awesome. It goes drop by drop by drop up until we've reached the point where it's neutralized. A lot of times we use an acid solution with like this indicator. The indicator tells us when it's been neutralized. So yeah, and how this would work, suppose I can give you guys a sample math here. Let's say, let me change this X. let's say we started with 50 milliliters of the acid here, and we don't know the molarity of it, okay? So, but we do know the molarity of the base is 1 molar. So let's just say, for instance, it took 50 milliliters of the base to completely neutralize this, okay? I made these numbers easy for you so you clearly see this. So if it took 50 milliliters of a 1 molar base to neutralize the acid, and in the acid we started with 50 milliliters of it, what would the concentration be? Well, I made it easy for you. The concentration would be 1 molar. So this is kind of what acid-based titrations is all about. It's using a known concentration to figure out an unknown concentration, okay? So let's go back to that definition so that way you guys can see this a little bit better. So like it says here, the process of adding a known amount of a solution of known concentration, that'd be like that base, to determine the concentration of another solution, that was the acid, is called titration. The point of neutralization signals the end of the titration. So that's why with the color change in the picture here, that would signal the end. You would stop. You would stop adding the base as soon as, boom, okay, it turns that last little bit. Then that's the way you know it's done. All right, we got a couple more vocab words for you guys. The solution of known concentration is called the standard solution. Indicators are often used to determine when enough of the standard has been used to neutralize it. The point at which the indicator changes color is called the end point. So what we could do is we could label this again. I'll let you think about it. Which one is the standard solution according to what I was telling you in the previous example? Hopefully you guys are all answering that this one is going to be the standard solution, right? So in that titration burette, that will be the standard solution because it had that known concentration of 1 molar. So then this would be your unknown concentration down here. But it's as simple as that. That's how titrations work. It's used to figure out the unknown concentration. So we got a couple more vocab words for us. When an acid and a base are mixed, the equivalence point is when the number of moles of hydrogen ions equals the number of moles of hydroxide ions. So I have 2 examples for you here to consider. So HCl, according to this balanced chemical equation, when I say balanced, let's go like this. I'll add the 1 so you guys can see what I'm saying. According to the balanced chemical equation, it takes 1 mole of hydrochloric acid to mix with 1 mole of sodium hydroxide to get 1 mole of salt and 1 mole of water. Okay, it's not always that simple as 1 to 1 to 1. Because if you look at this example, it's going to take 2 moles of hydrochloric acid to neutralize 1 mole of calcium hydroxide. And that will end in 1 mole of calcium chloride being formed and 2 moles of water. So it's not as simple, always as simple as a 1 to 1, like I showed you guys there with the titration example. Sometimes it takes 2 to 1, and that will just be from writing your balanced chemical equations. As you can see right here, it's a 2 to 1. So if I have 4 moles of HCl, it's going to require 2 moles of calcium hydroxide to neutralize it. Okay? Of the same strength. That's the other thing to consider too. If I have 2 moles of 1 molar HCl, it takes 1 mole of 1 molar calcium hydroxide to neutralize it. And then here's another example showing you that as well. So here's another one where it's a 1 to 2 based on the formula. So here's some questions that's asking us finding the number of moles of an acid to neutralize this. So it says, how many moles of sulfuric acid are required to neutralize 0.5 moles of sodium hydroxide? Well, for problems like this, you have to start by writing down the equation so we can see what it's going to take. So here's where your naming rules come to play. You have to know that sulfuric acid is H2SO4. You know sodium hydroxide is NaOH. And then you have to be able to pick out which ones are going to go together, because it's like a double replacement reaction. So it's going to be the sodium sulfate is going to be the salt. And you need a 2 here because sulfate is a -2 charge. And you're going to get water. Okay, this is where we're going to start. Now we have to balance this because we have to figure out the mole ratio. How many moles of this do we need to go with that? So I like to look for those red flags. In this case, there's definitely one red flag right here. I got 2 sodiums. So let's jump over here and put a 2. Okay, from there, I might just kind of consider looking at the rest of them here. So I got 2 hydrogens. 2 hydrogens makes 4. Well, over here, I only got 2. So I should put a 2 in front there. Now I believe we're balanced, but we should double check it. 4 oxygens plus 2 more makes 6. 4 oxygens plus 2 more makes 6. And now I got 2 sodiums, 1 sulfur, 1 sulfur. I know the hydrogens are good. All right, so I have my balanced chemical equation. I'll put a 1 here just so you can see it. Now let's answer the question. How many moles of sulfuric acid are required to neutralize 50 moles or 0.5 moles of sodium hydroxide? So we have 0.50 moles of this. Some of you guys can probably see right away that, oh, well, this is a 2-to-1 ratio, so this should be 0.25. If you can't see that, you can just go back to using your dimensional analysis to solve this problem. So you're starting with this amount of sodium hydroxide. We need to figure out how many moles of H2SO4 we need. It's a 1-to-2 ratio, so it's going to be 1 mole of H2SO4 to 2 moles of sodium hydroxide. You'll see these cancel, and it's essentially just 0.5 divided by 2, which gives us 0.25. Like I said, some of us can probably see right away, oh well, it's a 1-to-2, so if I have 0.5, then I need 0.25. Which that should make sense, right? So if I have 0.25 moles of this, I'm going to need 0.5 moles of that to neutralize it. All right, let's keep working here. This one says, how many moles of potassium hydroxide are needed to completely neutralize 1.56 moles of phosphoric acid? All right, so we have phosphoric acid, H3PO4, plus sodium hydroxide. Again, here's where your naming rules are going to come into play. It's going to produce a salt and water. In this case, it's going to be sodium phosphate and water. Then I like to look for those red flags. Well, I have 3 sodiums over here, so I definitely need to put a 3 here. The other red flag is, okay, well, I have 3 hydrogens here and 2 over here, so I have that odd number. Let's make them both a 6. So let's put a 3 here, jump over here, put a 2. Well, now that just changed the phosphate group, so you got 2 of them. So now I need to jump back over here and put a 2 in front, which is then going to change this value, because now you have 6 sodiums, so now I need to put a 6 here. And that will be balanced. You guys can double check it. So now what I'm going to do is go, okay, I have 1.56 moles of phosphoric acid. That's going to go here. And instead of setting it up with the dimensional analysis, I'm going to recognize that it's a 2 to 6 or a 1 to 3. So if I have 1.56 here, I need 3 times the amount of the base to neutralize it. So I'm going to take 1.56 times 3. So that means I'm going to need 4.68 moles of sodium hydroxide. And that should make sense, because it says how many moles of, oh, I'm sorry. This was going with potassium hydroxide, so I'll just switch this out. Switch this out. And over here. There we go. So how many moles of potassium hydroxide are needed to completely neutralize it? Well, it's a 1 to 3 ratio, so if I have 1.56 of this, I need 3 times the amount, 4.68. Makes sense. All right, I'll skip this one. I think you guys do that one on your own. Another way to signal the end of a titration is to use a pH meter. Like in that one picture, they had the pink indicator in there. We could just use a pH meter when it reaches 7. We know we've reached the equivalence point. And this is kind of what a titration curve would look like. And here's just another example of that. So what I'm saying is, if we didn't have an indicator, we could use a pH meter, which would be a little bit more challenging. The indicator works very well. Okay, so now we're gonna figure out these titration problems. It says if I have 50 milliliters of a 0.1 molar HCl solution, 50 milliliters of a 0.1 sodium hydroxide is needed to neutralize it. Makes sense. So we can use this formula right here. This is actually the titration formula that we're going to use. I'm going to add to it. I'm going to go divided by NA and divided by NA, because this is going to help us solve any sort of titration problem. Because this was a 1-to-1, you know, it was sodium hydroxide and then HCl. We didn't necessarily need to divide by NA and NB because it was dividing by 1, so it didn't really matter. But there will be problems when we're solving titrations where it'll be nice to have this, because one might be, okay, for every 1 mole, this one might be the 2 moles over here. So, all right, that's going to be our formula we're going to use. I'll show you guys a couple problems. So let's look at these ones right here. So it's asking us how many milliliters of a 0.2 molar HCl solution are needed to neutralize 50 milliliters of a 0.1 molar sodium hydroxide solution. Okay, this one I can see will be 1-to-1. Like if you were to write out the equation, you'll see that it's just going to be a nice 1-to-1. So we can use the one formula, which is the molarity of the acid, volume of the acid, equals molarity of the base divided by volume of the base. So then we just pick out our variables. So the molarity of the acid is 0.2, so 0.2. We're trying to find the volume of the acid because it says how many milliliters. We know the molarity of the base is 0.1, and the volume of the base would be 50 milliliters. So we just use that formula, solve it. It's pretty easy. 0.2 divided by times 50, and I get volume of the acid would be 0.04. Now I just want to double check. No, that should be good. So 0.04. Let's see here. Oh wait, no, I did that one wrong. 0.1 times 50. I'm thinking that doesn't seem right. It's 25. That makes more sense. That number makes a lot more sense because the strength of the base is 0.1, the acid is 0.2, so it's a little bit stronger. So you're going to need less of the acid to neutralize the 50 milliliters here. So that does make sense to me. All right, let's look at this one right here. It says how many milliliters of a 0.15 sulfuric acid solution are needed to neutralize 50 milliliters of a 0.45 molar calcium hydroxide solution. So for this one, I'm going to draw it out. I'm going to write the equation down just in case to see if it's a 1-to-1 or not. So I have H2SO4 plus calcium hydroxide. This is going to give us calcium sulfate and water. Let's see. So this goes to here. Yep, that goes there. We can see you got H2 over here plus 2 more hydrogens makes 4. So I need to put a 2 in front. Let's see here. 1 calcium, 1 calcium, 1 sulfate, 1 sulfate. We're good. 4 hydrogens, 4 hydrogens. Good over here. All right. Well, I'm glad I just double checked it. I wasn't sure if it's a 1-to-1, but it is a nice 1-to-1. So we can use this formula for this problem as well. So the molarity of the acid is 0.15 times the volume of the acid is what we need to find. We're going to neutralize 50 milliliters of a 0.45 solution. So now we'll just divide this by 0.15. So pretty simple math here. Times 0.45 divided by 0.15. So then the volume of the acid needed to neutralize it's 150. So, and if I'm looking at it, it makes sense because I need to neutralize 50 milliliters of a 0.45 molar base solution. So it does make sense that I'm going to need 150 milliliters of an acid that's only 0.15 because you can see the ratio there. So yeah, that one makes sense. All right, let's skip ahead here and let's find one. Let's find a problem where it's not always necessarily going to be a 1-to-1. Let's see here, that one. Okay, yeah, let's look at this one right here. So this one will not be a 1-to-1. I'll tell you that. So we are going to need to use this formula. Molarity of the acid, volume of the acid divided by moles of the acid equals molarity of the base, volume of the base divided by the moles of the base. Okay? So, when we're looking at this problem, we're taking sulfuric acid, we're mixing it with sodium hydroxide. This is going to give us sodium sulfate and water. Okay, however, we still need to balance this, so I need to put a 2 there. Let's see here, and then I believe we're balanced. Well, no, one more 2. Need to put a 2 there. Then we're balanced. All right, so here's one where it's not a 1-to-1. It's a 1-to-2. So we're going to need 1 mole of the acid for every 2 moles of the base. That's where this comes into play. N stands for moles. So there we'll put a 1 in here to the formula. We'll put a 2 in for the base. So now we can use the formula. It says if 25 milliliters of solution of sulfuric acid is completely neutralized. Okay, so we know we have molarity of the acid, we don't know. Volume of the acid is 25. And we know it's going to be divided by 1. Equals, the molarity of the base is 1. The volume of the base is 18 divided by 2. So we just solve this for the molarity of the acid. So you're going to have this times 25 equals 9. Divide both sides by 25. 25 divided, 9 divided by 25. And the molarity of the acid must be 0.36. So there it is. And if you need a little bit of help on that, this kind of explains how to do it as well. I think what I'll do is I'll leave these ones for you guys. So yeah, you guys will have a book assignment. Make sure you look for that on Schoology, and we'll see you guys next time.